Today I will stop for today. And next week we will have a live class as well to continue this chapter. Okay, because this chapter is for your assignment too. I want to teach the whole life. Okay, so I want Queen. Okay, so we will the second most important topic aside from ERD. Yeah, so it's about normalization. We call it normalization. Okay, which is just
Today
the title for the chapter. But the thing that we will talk about in this chapter is normalization. Okay,
today
so
I
lecture is quite long, but even today I will not cover all of these slides because I don't want to teach you in a rush in case you cannot hear me clearly because of my voice. But I want to be fresh and healthy as well to teach you this topic because it's very important. But you can also look into the Instagram. I have several videos on normalization. You can repeat that, or I can share the last year's, I think last 2 years playlist in YouTube channel as well. Okay. So today, by the end of today's class, you guys should understand already this one, the different anomalies state of database. There are three. There will be three anomalies. We will go through one by one. And for normalization, we have first, second, and third normal form for this uh, first part. Okay, but today I will cover only the first normal form because if you this is crucial because it will define whether your second and third normal form will be correct or not. So you have to start with a correct first normal form. Okay, so ada dua benda. There will be two things that we will learn: the anomalies, why normalization, and then how to apply the first normal form. Okay, so what is this normalization? Okay, so you have learned ERD, right? You have learned ERD, and maybe you can take some more time to relearn it. I haven't looked into assignment submission, but my idea is to start marking this week and return to you. If you guys like perform below average, my expected average, I will give you options if you and your group want to redo and resubmit to me. But there will be ceiling marks. I just want to help you in the sense of like, I understand it's hard to get all the knowledge in online learning situation. Okay, but so I will try to finish that early, give you back if necessary, so you can resubmit to me. Okay, the ones yang below average lah. Okay, the ones yang okay, I will not ask you to resubmit. There's no extra mark for that. Okay, so for ERD, you learn how to create that database or how to design your ERD and how to design database from top down. Meaning you have case study, and then without data, no data. So you develop the model, something that looks like this lah. Okay, so you develop the model. So without data, you don't know if this design is actually need more improvement or not. Okay, but the software development cycle, yeah, the one that you've learned, the agile development. Every time you develop a system or something with database, there will always be improvement. Like your antivirus, you will have like your apps in your phone, you will have updates every now and then because there will be something to improve on. So it's the same with ERD. Like the one that you have the assignment. Last time, the Hombangjang Cake House, they don't have database. So you just create with whatever they have. Okay, that is ERD. You create from top down, usually from case study. Normalization is you create ERD, you create the diagram from existing data. From existing data. So it means that this style is bottom up. Data, analyze the data, analyze the existing whatever they have. Like for example, if Hombangjang Cake House give you all the receipts, all the Excel file, and then from there you have to design an ERD. This is the process to design ERD from data is what we call normalization. So I hope you get this difference. Okay, it's important. So normalization here, the process of evaluating and correcting table structures. Because if you don't have any database design background, you cincai, you just just create table whatever makes sense, okay, and put your data wherever it makes sense. So if you are a database designer, you can see if the system has some problem. You can actually, after after years of experience, you can actually think and you can imagine where something has gone wrong for the system. Okay, so we want to correct the table structures because of these existing structures has a lot of data redundancy. You know what's the meaning of redundancy? Okay, I give you the meaning that I always use and you easy to for you to remember. Unnecessary. How to spell unnecessarily duplicated data. You have student table, there's student data, and then in the course table you also have student name. So this is unnecessarily duplicated data where you can find the name in student table. There's no need for you to key in the name as well in other table, but the metric number is okay because the metric number will act as a foreign key in another table. Okay, so we will see what are the apa nama the redundancies lah. Okay, some examples. So when we minimize data redundancy, we will also reduce data anomalies. Anomalies is something like that needs to be corrected lah. Okay, needs to be corrected, like some obvious not in a programming sense. Some obvious kesilapan, wrong data placement, something like this. Okay, so in normalization, in your course, you will cover first normal form, second normal form, third normal form. This one is mainly for your assessment, for your assignment 2. And then we will have fourth normal form and BC normal form. This one for your knowledge, it will be tested during the exam. Not drawing, but just theoretically from your knowledge. Okay. So normalization. So you have 3 stage: 1 NF, 2 NF, 3 NF. So basically, the one in a higher stage is better than the previous stage. So 2 NF is better than first NF. 3 NF is better than 2 NF. Okay, so higher, but the highest level of normalization, we have this one actually. If you read like advanced textbook, I think we have up until 5 NF. Okay, but these 3, we call it the higher level. So the higher level or highest level of normalization is not always most desirable. You will see how. You will see why. Okay, so denormalization is the opposite of normalization. So denormalization meaning from a higher level form, normal form, you go one step down. For example, you see a set of tables or set of entities that are in 4NF. Probably it produced too much table, so you want to do a denormalization to go to the third normal form. Okay, So in business cases, like real life cases, the usual one we do until 3NF. Okay, 1NF is a must, 2NF is also a must, but 3NF is that sweet spot of basic good design, good database design. Okay, so denormalization produces a lower normal form. So example just now, you want to go from 4NF to a 3NF. Okay, so this one it can increase the performance, but there is a possibility we don't eliminate all data redundancy. Okay, so I will draw you something. So this is data, for example, data given by your client. Okay, maybe they give you in Excel file dot XL like that, and there are a lot of columns, so many columns, because it's a business, probably business file, so many columns, everything is in there. So what normalization do is you analyze these columns, and you see the data will help you to break down this column, and then in 2NF there will be some rules. So from one big table, maybe you produce two tables that has relationship. And then from here, from 2NF, there will be some more improvement needed, and you will probably end up with 4 perfectly related table. So for example, the numbers is not fixed, okay? So it depends on the design. So based on the client's data, you can do some improvement when you do normalization. Okay, you can add on some column with justification lah. Okay, because you are the expert, you are the database designer, your clients need your help. So you don't actually take all and dump all. You can improve wherever necessary, but usually it happens in the the need for normalization. Like I said before, we want to reduce data redundancy. That will reduce the anomalies, the obvious errors. Okay, we can say lah errors. Okay, so if we reduce this, we eliminate anomalies, eliminate redundancy, we can ensure the consistency. It means that whatever data is the latest will be there. There's no confusion of duplicated data, and there will be no confusion of which one is actually the correct one. Okay, this is what happens a lot if people just do tables like they do in Microsoft Word. Just random column, whatever fits, whatever makes sense. Yeah. So we as a database designer, we help them to create proper table with relationship, so some automation can happen. So the foreign key will help, retrieve data from related table and so on and so forth. Okay, so the normalization is used while designing and redesigning a database structure, right? So it analyzes the relationship among attributes. Okay, so in a table, where is the attribute? The header. These are the attribute of the whole entity. Okay, so entity, for example, entity is student. So here, metric number, name, email, program. So these are the attributes, the column head. So analyze the relationship among these attributes within each entity, and from there we will determine if the structure can be improved. All right, so have 1 minute to read this one first. One moment. You just read this slide first. Okay, so example, a company that manage building projects. So this company charges its clients by billing hours spent on each contract or each project. Hourly billing rate is dependent on employee's position or job title. Periodically, a report is generated that contains information such as displayed here. Okay, look at this table. I give you 1 minute. Look at this table and decide if this is a database view or normal Excel table. Sorry, Amir. Submit. Submit. Okay. And then you see which questions yang salah. Okay. Okay, so this is a sample report. So obviously, this is not database. Okay, you know, database, every cell needs to have one data. Okay. Okay, so look at this. We have here project number, project name, employee that are involved in the project, the employee name, meaning this is the staff number, job class of each employee, the, what do you call it, the job title, charge per hour for the project, and how many hours have been worked on in this project, and the total charge. So this is the total charge for each member. This is total charge for the whole project. Okay. So you can see here, database designer, in this table alone, database designer earns more than other people, more than programmer. This is true in real world. So that's why I said database, playing around with database is actually interesting, exciting, and I like that. Okay, I like given a problem and need to be solved using database. So you can have that same vision, right? So what you can see here is a very pretty layout for a report. Okay, report. You can see this clearly. Oh, okay. Evergreen project, 5 people who are there, job class, blah, blah, blah. Can you imagine what will be some possible human error that can occur in this table? Here, I give you one. You can see here there are same stuff. For example, 104 here is N. Okay, N. There is a possibility, for example, the clerk misspell analyst in one cell. Okay, that is a simple human error lah. But sometimes, because of it key in manually, probably the error is here. Okay, probably an error happens to be, she typed here 9600 9675. This is the same person, same title, supposed to have same charge per hour. So human error can do this. Be typing manually so many data, they can do. They can this type of error can happen. Okay, so what we want to do with normalization, with database, with linking the key, foreign key, and so on, is to avoid this thing happening. Whatever job class, charge per hour, keep it in one table, something like this. Okay, so whatever you want to pull the value, pull using the primary key, become foreign key in another table. We want to avoid key in the same thing over and over again, which is what we call redundancy. Okay, so this is if we convert into a database view, but what can you see now? What can we call this area? Okay, 4-letter word, not the F word, the N word. Okay, can you guess? Null. Good. It is null. In database, it's we don't want null. We avoid wherever possible, especially in a column that is most probably a primary key. We don't want null. Okay. So what can we do for this table? Okay, we need to prepare it for normalization. Okay, we will look into that later on. Sekejap, I call my kid. Sorry. Kasi pa hantar tau, Kori. Fill in. Oh, betul lah. Submit. Okay, so there are 3 anomalies: update, delete, and insert anomaly. The example that I told you just now, the wrongly key in, that falls under insert anomaly, but there are other example as well. Okay, so this is a simpler example, and I will explain. First, what is it? Update anomaly. Okay, update anomaly. That one is plural. For singular, it's with a Y. All right. This is a table, just a random table, not a database table. Yeah. So what can cause update anomaly? Okay, you see here there are several data with the same students. So we have here Jones, Richard. This is the same student. Okay. The difference here is that Jones take these 2 courses, Richard take these 2 courses. So the address here must be the same. Every time you key in a Jones data, you will key in again S21, key in again Edinburgh. Okay, and then the course. So update anomaly is if Jones move somewhere else, and then they need to change his address, the clerk or whoever, the person who will change this data, will have to change all of John's address to the new place. For example, Scotland lah, contoh. Okay, there is a possibility that he or she miss one row or many rows. Okay, so at the end of the day, we don't know which one is the latest data, because when you retrieve, there will be several addresses, and you don't know which one is the latest, the current one. You don't know. This is what we call update anomaly. Not only address, maybe the the phone number, something that needs to be edited, something that needs to be updated. This can happen. Okay. Second one is delete anomaly. Update anomaly, redundancy causes update errors. Okay, you know the situation lah. It can be missed data, okay, or incomplete update. Okay, you can goreng whatever, but understand the concept that there is a probability of some rows not updated by the person. Okay, or they wrongly update a different zones into Scotland. That is dangerous. Okay, so that is update anomaly. We want to avoid that. Second one, delete anomaly. Let's say Smith here drop the course, drop physics. So in order to delete Smith and his physics course, what do? You have to delete the whole thing. If you delete the whole thing, the Smith data, like his student number, his name, his address, will be gone from the table. This is delete anomaly. If this is the only table you have for your organization or your clients, whenever they need to delete, they will like, just delete the whole row, and then the student is going to be a ghost in the university. He is there, but his data is not there. Okay, so it will lead to different problems. So this is delete anomaly. And then the last one is insert anomaly. All right. So let's say there are new students coming in. Okay, new students coming in, or new course is going to be added to the table. So, for example, you want to add new course 9400 French, for example. And then different one, biology 9501. Sorry, not here. French, bio. You see how wrong this is? Course number and then course name, but empty because no students is taking it yet. So null, null, null. Okay, especially if this is you know, like a composite key. This one is obviously wrong. So this is what we call insert anomaly, where you want to insert some new data. Okay? For example, you want to insert new student pools. It's the same. B, S32, Ali. But then this one is empty. Okay. So insert anomaly is when you have to key in some new data, but then you don't have other data available because it doesn't happen, it's not happening yet. So this is causing the insert anomaly. So in the end of the day, your table will become like loopholes everywhere, ronga, so many null places. Okay. So the structure of dataset in table 9.1 does not handle data very well. Okay, this one, 9.1, this one. It looks pretty, but it does not handle the data very well. Okay. So table structure appears to work. Report is generated with ease. Like I say, pretty, yeah. May yield different results depending on what data anomaly has occurred. Okay. And the relational database environment is very suitable to help the designer to avoid data integrity problem. So what are the integrity problem tadi? The anomalies, okay, and the redundancy, the inconsistency, these all things are. These are all data integrity problems. All right. So normalization is to ensure that each table follow the concept of well-formed relation. So this one is chapter 2, if you don't know it yet. Chapter 2, your business rule, your connectivity, one to many, many to one, okay? And one to many, one to one, many to many, okay? So you have that rule already. You understand that basics already. So now the normalization process, the objective is to ensure that the table conforms or follow this concept. Okay, so each table represents a single subject or entity. No data item will be unnecessarily stored in more than one table. Okay, unnecessarily lah, macam name, job title. You don't have to key in everywhere. Every time you key in Anna's name, you have to key in the job title. There's no need. Yeah? Only one place is enough. All non-prime attributes are dependent on the primary key. Non-prime attributes are the ones that that needs the primary key to be dependent on. Okay, we'll see after this. And each table is void of these three anomalies. We want to make sure when you insert, you can insert a complete row, very minimal null, and you can delete without disturbing the original data. Okay, and then you can update everything only once with latest data. Okay. So the objective of normalization is to ensure all are in highest form. In this case, it's only 3 and F. Okay. But Oh, okay. The objective normalization, highest form. Highest form probably BCNF, but it's not suitable for business environment. It will become too many small table. Okay, that's why it you have to follow your logic as well. Okay, so normalization works one relation at a time, and it progressively breaks table, like I said in previous slides, into new sets of relations. So from one big table, maybe break into two, whatever the situation is, you will see. And from these two and a half, maybe you come up with four related, yeah, new set of relation based on dependencies. Okay, so these are the characteristic. I will only cover this today. I don't want, because my when I have flu, when I am not well, my brain is, mental fog. I don't want to mumble words that's not understandable. Okay, so the first normal form, you have to make sure whatever data, the report, or the Excel file, whatever lah, is in proper table format, no repeating groups, and identify the primary key has been identified. Okay, and then some other things. So first normal form is a big step. Is so many things to do in the first normal form. Okay, so second normal form is dengan syarat you have to already be in first normal form, and then no partial dependencies. We look into this later on. Third normal form is you already in the second normal form, and you don't have transitive dependencies. This one is higher form. We will go at the part 2. Okay, so all right, dependency concept. Okay, just look at this one. This one is probably hard to understand. I know this is from the textbook. Okay, so given a relation and your relation has this attribute, for example, A, B, C, D, and the attribute A determines the value B, C, and D. Okay, and then this is extra. BC determines value D. Okay, so functional dependency means B here, for example, B. Okay, B is fully functional on A. Okay, if every time you key in the value A or you search the value A, you will get the same answer for B every single time. For example, in student database, Unima student database. For example, I key in your matric number 11111. I will get city A every single time. It's the same person, same student that carries this matric number. If I key in 11111 and then one time I get city, another time I get Ani, so this is wrong. It means that this B here does not dependent on A. But if every time I key in this metric number, I will get the same student. Okay, so that means student name is functionally dependent on metric number. Okay, you can write it like this. Metric number decides the value of student name. Okay, so this is a general definition. Again, berbeli-beli is hard to understand unless you are very good with long sentences. This is another one is fully functional dependence. It's the same, but it only happens with composite key, like B and C here. So attribute B, attribute C must be together, and then you will get the D, the same value of D every time. This happens in the composite entity lah. Okay, usually in composite entity you have two primary keys. You will see in this example. Okay, so this is the one that has been converted from that beautiful report, and then you still have null. But if you look properly, you know the value of this null. You know these 5 people are actually in this evergreen project. So what do? How to fill in this null? You You fill in the data. You know evergreen is project number 15. Okay, so the first step before you go into before you complete your first normal form is to prep. I call it prep the table. It's not formally in textbook notes, but this is how I teach my students. We prep the table. This step is important because it will help you to select the best primary key combination. Okay, so we fill in. I think I have the full table. 22, 22, 25. Yeah, you fill in because you know the actual data. Unless you really don't know, then you can leave it blank. This type of blank data is something like phone number, maybe email address. That can be, you don't know. But this one is obvious. The null area, you really know what is actual data. What's the actual data? So you fill in. So no nulls exist here. Okay. So this is how a first normal form looks like. We will do this shortly. I want you to absorb this figure. Okay, this is what we call dependency diagram. We'll see this word a lot in your assignment, in your exam. The whole thing here is dependency diagram. Okay, this is all of these words here is what we call relational scheme. Okay, all of these have meaning. So this one describe the whole dependency diagram. Okay, this one you can see it. It follows the attributes listed in the diagram. Partial dependencies, it shows which attribute is dependent on which key. Okay, transitive dependency is a non-key attribute, not the primary key, but then it also decides the value of some other attribute. Okay, I want to go with you one by one. Okay, all right. So partial dependency is, for example, you have a primary key. I think it's hard to explain now. Let's do the first normal form together, and I will explain everything there. Okay, I think the susunan here is not that well. Okay, so conversion to first normal form. Step, eliminate repeating groups, identify primary key, identify dependencies. Dependencies are what we call this arrows. Okay, you see, mental fog. Arrow here are what we call dependency. Okay, but then in this textbook, they forget the number zero. Yeah, prep the table. Fill in the null value first. Okay, this will help you a lot. Fill in the known null values. And then you can do the number 1, 2, and 3. Okay, so repeating group here means a group of multiple entries of same attribute type. Okay, it gives the major reason for redundancy. Okay, we don't want that, so we eliminate it. This is the example. For example, student name, student ID, and then student tell 1, 2, and 3. This happens a lot in normal business operation. This is what we call repeating. It's the same thing, phone, student, phone, but not everyone has 3 numbers. Not everyone even has 2 numbers. Okay? Majority, we have only 1 number. So what happens with the student with only 1 number? Null, or both null. Terrible table, ugly table, yeah? Same with this one, student, course 1, course 2, course 3. What about student taking 6 courses? Do you have to add until 6? What about the one with CoQ 7, many courses? It is wrong. It's obviously wrong here. You know there is a relationship between student and course, 2 different things, 2 different tables, and you can design it in a better way. But doing like this is what all repeating group. So we want to eliminate this. Okay. And then after we eliminate that, we identify the key and then we draw the dependency diagram. Right. So that's why I have this table again. So I can show you how to draw. This is original report. This is the prep table. See, the values are filled in. Okay. Value dia sudah isi. Okay. Alright, so now the table looks good. You can process it to first normal form. First normal form. So what's the first thing that you need to do is to list down the attribute number, attribute name here into one single row. Okay, the one single row of boxes. So we have here project number, project name, employee number, name, job class, charge hour, charge hour, and hours. Okay, so these are all the attributes. We only take the name of the attribute. You do this. This is the first step. Okay, and then the second one, you need to define which one can be the primary key. This is why prepping the table helps you a lot. If you fill in the data, you can choose the. If you don't understand normalization pun, you are very close to choosing a correct primary key. Okay. All right. So primary key must be unique and not null. Always remember that. Unique, not null. Unique, not null. So project number only, can it be primary key? 15, 15. Already duplicate. Project number alone cannot be primary key. What if project plus project name? Project name is not a suitable primary key candidate because it's in ABC. For key, we want to have characters or numbers. Easier to use numbers. Okay, because typing a name can give possibility for human error. So numbers or auto running numbers is the best. Okay, so we eliminate this one. How about project number plus employee number? Can it make the row unique? Let's see. 15103, 15101, okay, different. 15105, okay, different. Because there will be no name entered twice in the project. Okay, so the possible primary key here is project number plus employee number. So what do you do with that? You underline it in the dependency diagram. Okay, to label that as your primary key. Okay, follow so far? I hope you follow. We recorded the lecture as well. So the next step is you draw the dependency line. Okay, the line here is very important because so many students, semester after semester, they do it wrongly. Although I said so many times, for primary key there will be no arrow, like this. Simple line but connected. Here it shows project number and employee number are the primary keys. Okay, so these two keys will decide the project name. Yang lain ni barulah ada arrow. Okay, in this table, in this big table, these two is unique. But with this project number and who is it, you know which project it is. You know who is the employee. You know the job title, how much she is paid, and how many total hours is billed. Okay, so partial dependency. Okay, so we have two types of dependency. That was in the previous slide. We have two types. One is partial dependency, one is transitive. Transitive dependency. Okay, so partial dependency means an attribute that is that is dependent on a part of the primary key. So for here we have two PK. So a part of these two PK is one primary key. Okay. So let's say here project number. What does this every time you key in the project number, which value that you will get the same value every time? Every time you have number 15, which one will be the same every time? Not this one, not this one. Yeah, because this all of these are 15. Tapi ini June, John, Alice, William, different, right? So every time you have number 15, you will get project evergreen every single time. So it means that project number decides the value of project name. Okay. How about employee number? Employee number, every time you key in, let's see, 103 only once. Let's find someone that has many visible. Okay, who is it? 101, 105, 105 lah, 105. 105, you will get Alice K. Johnson. Let's check. Oh, okay. Alice, another 105? No. So every time we key in employee number 105, we will get the same employee number. Employee name, sorry. Project name, employee name. What about the other things? Will you get the same as well? Alice K. Johnson, database designer 105 357. Alice K. Johnson, database designer 105, but this is 647. So basically, the employee number will decide the value for this, and charge per hour. It's the same every time for Alice K. Johnson, staff number 105. Okay. So, employee number decides the name, the title of the employee, and how much she is charged per hour. Let's check for other values. Okay, 114 here. Analyst Jones, 114. Yes, same. Analyst Jones. How about job class? Application designer. Yes, same. Application designer, $48. $48. Same. Meaning this arrow here is correct. So after you after you draw your partial dependency, you label it with PD, saying it's partial dependency lah. Okay. All right. The one that is not the same, you don't label. There's no need because it's not. Employee number does not decide how many hours you worked on a project. It doesn't. Okay. Okay. So we have here PD done. What about transitive dependency? Transitive dependency is non-key, okay, not primary key, non-key attribute deciding the value of another non-key attribute. So this one is something that is not primary key, but every time you have that data, you will get the same value of some other attributes. Let's see here. Okay, employee name. Okay, let's see job class. It doesn't matter who is holding the job class. Is all database designer paid 105 per hour? Yes. Let's see again. Database, okay, 105. What about programmer? Programmer 3575. Programmer 3575. 3575. So it means here, doesn't matter who you are, if you are a database designer, you will always be paid 105 per hour. Doesn't matter if it's me, if it's you, or if it's your friend. If we have the same title, we will be paid the same amount. But then job class is not a part of primary key. So this is where transitive dependency happens. Job class decides the value of charge per hour. Then I label here TD. TD means transitive dependency. Okay? Are you following so far? Let's see the answer. Betul. Of course lah, kan? Project number, employee number is primary key. No arrow, yeah? You see? These two decides, on the top of the dependency diagram, you have to put arrow for all attributes. That is decided by these two. Semua, memang all of this. But below this dependency diagram, you will break down partial dependency, transitive dependency. Okay, it happens below here. Some of students in my previous semester, every arrow they put below the diagram, and I cannot see clearly which one is functional dependency, which one is transitive, which one is partial dependency. Okay, there will be three. Yeah? Atas, on top here is FD, functional dependencies, like the one I explained above. And below here, partial and transitive. Okay, so what do you do next is to write the relational scheme. Every dependency diagram must be accompanied with the scheme. So the scheme is 1NF. 1NF because we don't have any table name. So you list down all of the, you put the primary key together, project number, employee number, underline, and then the rest of the attribute. Employee name, job class, okay, charge per hour and hours. Okay, and then you draw your, you write the scheme for your partial dependency, which is number one, project number, define the value of name. Okay, sama lah macam matrix, define the value of student name. And there is another partial dependency, employee number, define the value of emp name, job class, and charge per hour. And then you have transitive dependencies, okay, which is the job class, define the value of charge per hour. Okay, so the tips here that I can see, if you have two primary key, you will have either one PD or two PD maximum. If you have only one primary key for the whole dependency diagram, you don't have any PD. Remember that. If you have only one PK, there will be no PD. If you have PD, but then one PK, something is wrong. Okay. For a relation, the dependency diagram that only have one primary key, the other dependencies will be transitive. Everything will be transitive. Okay. This is a tips to decide the PD, but there is no tips to decide the transitive dependency. Everything depends on the data. Okay. So this is the the answer lah. So basically it's the same, but this is step by step. Okay. Ngam-ngam sejam. 1 hour. My nose is very runny now. Do you have any questions, or do you want me to repeat anything? Let's see. Good. Do you have any question? Or, what you don't understand now, if I re-explain it now, you will keep it in your brain. So lately I've been reading a lot on, keeping my focus, growing my brain. Your brain can grow actually. You can use the 100% capacity of your brain. Every time you learn something new, your brain expand, and it keeping it that way because every day, if you learn something new every day, you will finally use the most of your brain. So using 10% of your need to repeat. So next week, thank you. Next week we will also have live class, okay? Because I want to continue, and then I want to quiz you a little bit during class, okay? So next Thursday we will have. So hopefully I am better by then, okay? Hopefully my flu has gone away. But I will upload this file juga lah. Okay, I will upload this part. So next week we will go to second normal form. Okay, so your first normal form is complete, and it's the biggest one lah. It's the toughest one. Once you have your PD and TD, everything else is simpler because you just need to break down the table. Okay, but the steps I need to repeat many times. But today I have no energy to do that. Sorry, I'm sorry. Yeah. Okay, so next week we will continue on the second normal form, third normal form, and then briefly give you the knowledge of the higher normal forms. Okay. YouTube is available. I will give you the link. You can watch. You can watch until the third normal form. Also fine. You wait until the lecture. Also fine. Okay. Someone wants to ask question? Ada suara-suara. Thank you. I hope nothing. I hope it's only flu, not something else. Every time, this is the time that you don't want to have any flu or cough. You keep smelling things and tasting things because you're afraid that you will lose that sense of. But I don't have COVID lah. No, don't worry about it. Just simple, just flu because my baby is having flu. Okay, so if you don't have any questions, don't forget next week live class again. Okay, we will see each other next week, Thursday, 12 to 2. Okay, eliminate distractions, focus because your assignment 2 will come up as well after class next week. Okay, all right. So I hope I get well soon as well because I want to mark your assignment 1 already. And I haven't checked, but I hope everyone has submitted. If you have problems, never come to me last minute. Okay, I cannot help you last minute. Right? Okay, so if you're done, you key in your day one. Thank you. I will see you next week. Bye bye. Yes.